All right, let's review Unit 3 so far. We've been talking about algebraic expressions. These are different from Units 1 and 2, where we talked about rational numbers, because algebraic expressions introduce a new thing called a variable. Now the question is, what is a variable? Think about that word. The word variable has the word vary in it. We can think of this as some number that either we don't know or can change. It can vary. We usually use a letter, so we'll use Z, A, P. The most common one you'll see is X, just to represent some number that we either don't know yet or that we can change. We can think about a variable as a little box inside of which there is a number that we might call X inside of it there. So what can we do with these variables? Well, we can do pretty much anything we can do with our numbers. We can add things to them. So we can say some number X plus 3. We can subtract. We can say some number X minus 3, some number X times 3, or some number X divided by 3. Now, there are certain ways that we like to write these that mathematicians have agreed upon. X plus 3 is pretty good. X minus 3 is pretty good. X times 3, what typically happens, we know that we can swap these things around. We know that 1 times 2 is the same thing as 2 times 1. So we could write X times 3 as 3 times X. And we also know to this point that if we have two things multiplied with each other, we can sometimes get rid of that symbol in the middle as long as it doesn't obscure what we're actually looking at. So we can actually write X times 3 or 3X's as 3X. And all this means is that we have 3 of that number. That's all it means. Similarly, if we have X divided by 3, we know that if we have 1 divided by 3, we can write that as 1 over 3. And so just the same, we can write X divided by 3 as X over 3. And sometimes we might even see this written as 1/3 times X. Something like that. All that means is that I've got some number X, and I'm going to cut it into 3 pieces. So we can do all of our normal math operations with variables, just like that. Now, in algebra, we will see different variations of this pop up. Sometimes things will get a little more complicated, but there are easy ways to identify what to do and to simplify things. So that's really the goal in algebraic expressions so far, is to simplify our expressions. There's 2 main ways that we do that. The first way is to combine like terms. To combine like terms. Now, we talked about these words in class. We talked about what does it mean to combine, and people said, well, that means when you add or put together. And I liked those definitions. When we talked about something being like or alike, we talked about them being similar or the same. And then we had this word, terms, that we weren't super duper clear on. All a term is in an expression, if you have 3 plus 2 plus 8, each of these items in between our operators, remember, our operations or our operators are things like plus, minus, all that. All these numbers in between, these are terms. In fact, here we would combine our like terms normally by doing 3 plus 2 plus 8. The quickest way I see that is 2 plus 8 I know is 10, and so 10 plus 3 would be 13. Now, we can do the same thing with our algebraic expressions. let's get rid of this stuff here. So what happens if we have 3x, remember that's just 3 times x, or 3 x's, and we add 7 to that. Maybe we add 10 to that. And maybe we add 5 more x's. Now this starts to look a little bit scary, but it's really not that bad, because the thing that we're going to do is we're going to identify our like terms. In algebra, we have variable terms. So here I've underlined in red what we would call our variable terms. These are any terms that have a variable in them. So notice I've got x in both of those. So I have 3x and I have 5x. Now if I have 3 x's and then I add 5 more, I think that most of you can probably see that, hey, what I've actually got here is 8x. And so when we get our variable terms all together, to combine them, we just look at the number that is multiplying the x, the number, like 3 and 5, and we add those up. So here we had a positive 3, a positive 5, we get a positive 8. And in fact, there's a fancy math word for that number that is multiplying our variable. It is called the coefficient. We talked about this word in class a little bit. We talked about meaning together, like cooperate. And we talked about efficient, meaning getting things done. And so in fact, when we talk about a coefficient, we're really talking about a number that is getting things done together with a variable. So we've got this number out front here, which we call our coefficient. Well, what about the rest of this stuff? We've got some other things going on here. We've already combined our variable terms there, but we also have this positive 7 and this positive 10, and those don't have a variable with them. Those don't have a variable. So what we call those are constant terms. Constant terms. And when we talked in class, we talked about the word constant. You guys told me it means just stays the same. It's always the same. So in fact, this one is very different from our variable term back up here, because a variable term can vary when that variable changes, but a constant term is always going to be the same. A 7 is a 7 is a 7. So we can actually combine these separately. So we can do 7 plus 10. And you guys could definitely tell me that that is 17. So now we have combined our variable terms. We got 8x. We've combined our constant terms. We got 17. So now all we're going to do is bring those things back together. We have 8x plus 17. And that right there is our simplified expression. We can't simplify this anymore because notice we don't have like terms. We don't have any like terms to combine. We just have 8x, which is our variable term. And we have 17, which is our constant term. We cannot combine those. We cannot combine those. Now, before we move on to the second way to simplify our expressions, I do want to do one more example with combining like terms, just so you can see a few strange things that might pop up. Let's talk about 8x minus 4 plus 2x plus 9 minus 3x. Let's talk about this one for a second, because now we see there's a couple more terms. There's like one additional term. We can actually have as many terms as we want to write out or as we're given. But we're going to do the same process, and we're going to notice just a couple things. First thing, we're going to pick out our variable terms. We've got a positive 8x here. We have a positive 2x here. And then something interesting happens right over here. We have a negative 3x. Because we're subtracting 3x, we have to think about this as negative 3x's. So that when we combine these, when we do 8x and 2x. We're going to subtract 3x. And again, we can really just focus right in on those coefficients. We've got 8 plus 2 minus 3. And of course, the first thing I'm seeing 8 plus 2. I know that that is 10. And then 10 minus 3, well, that's just going to be 7. And so, in fact, I have 7x. We are not done. We did our variable terms. But we have to go back and do our constant terms. So I'm seeing, again, this 4 it's being subtracted. So it's actually a negative 4. We get a negative 4 and a positive 9. So as I combine my constant terms, I have a negative 4 plus a positive 9. And I know that if I'm 4 in the negatives and then I add 9 back to it, I'm actually going to end up at 5 in the positives. So I have plus 5. 7x plus 5. There is our answer. All right. So we talked before, let me scroll up here just so you can kind of review. We're talking about simplifying our expressions. The first thing that we learned was combining like terms. That was taking our variable terms and combining them together by adding up those coefficients and then adding our constant terms together. Well, let's think about the second way that we can simplify our expressions. The second way that we can do this is a thing called distribution. Distribution. You might hear it talked about as the distributive property. You probably remember something about this. Let's think about it without variables just for a second. If I have 2 and I add 3, I know that that is going to be 5. I know this. This is a math fact that I've memorized. Now, what if I have a couple 2s sitting out on my table? Say I've got my dining room table at home. I've got a 2 and a 2 and a 2 and a 3 and a 3 and a 3. Well, you could say that I actually have 3 groups of 2 plus 3. They're groups of the same thing. And before we've seen this, so we've seen this little parentheses, 3 times 2 plus 3. And now with Gemma, we would typically do our stuff inside the parentheses first. So we would see that this is 5, and then 3 times 5 would be 15. Distribution gives us another powerful way to look at this problem. If we have 3 times 2 plus 3, well, like we saw in the table right up here, we actually have 3 2s and 3 3s. So we can think of this as 3 times 2, and then we would add 3 times 3. So we're taking this multiplied 3, and we're bringing it into the 2, and we're bringing it into the 3. So let's see what we get. 3 times 2, I know that that one is 6. 3 times 3, I know that that one is 9. And then 6 plus 9, well, hey, look at that. It brings us right back to 15. Now, in fact, we can do this with algebraic expressions as well. So let's say I have, I have x plus 4. And I'm going to have 6 of these groups. So if I was looking on a table, I have an x and I have a 4, then I would have them 6 times. So I would have my table right full of x's and 4s. Now, it doesn't take too much to see, well, hey, I've got 6 x's and I've got 6 4s, and we can do the same thing here. So we can do 6 times x and 6 times 4. Let's see, 6 times x is just going to be 6 times x. We don't know what x is yet, and maybe x can change. So we're just going to leave it as 6 times x. And we're going to do 6 times 4. So we're going to add 6 times 4. Well, we talked a little bit earlier just about how I can write this a little simpler. I can write it as 6x. And 6 times 4, I know from my times tables, is 24. And there is my simplified expression, right? Just like that. We distributed that 6 into the x and the 4, and we got 6x plus 24. And if we had added all of those on our table up, we would have 6x's there And 4 plus 4 plus 4 plus 4 plus 4 plus 4 is 24. Now let's look at what happens when certain things maybe look a little bit more complicated. Let's look at -3 times 2x minus 4. We're going to do the same thing, but notice now that number outside that we're going to bring in is a -3. So we've got -3 times 2x. So now we have 2 x's in here instead of just 1. And we're going to bring this over here as well. So once we're done with this, we're going to add -3 times -4. So -3 times -4. Let's start over here. We've got -3 times 2x. Negative times a positive is going to be a negative, so I know that. And 3 times 2, I know, is 6. So we've got -6x here. Let's look at our constant term. We've got -3 times -4. I know that that's going to be a positive number. And 3 times 4 is 12. So here we have -6x plus 12. What happens if we have a lot of stuff going on inside? What happens if there's a lot of stuff going inside? Well, we can still distribute. We can still distribute. We can do 2 times x plus 2 times 7 plus 2 times 2x plus 2 times -4. Now, of course, this takes a few more steps, but we can still do this. And in fact, when we start to see longer things inside of the group, we can start to see why some people call this the rainbow method. Because, of course, all those little arrows that we just drew look like a rainbow. Now, I would encourage you to remember this as the distribution method or the distributive property, only because more people will know what you are talking about. So we've seen two major ways to simplify our expressions. We've seen combining our like terms. That was when we saw all the variable terms and the constant terms, brought them together. And the other way was through distribution, by taking that number outside of the group and multiplying it into the group. Now we will see problems where we have to do both of these things. We will see problems where we have 3x plus 2 times -x -4 plus 10, something like this, where we see some terms kind of by themselves, and we do see one group of stuff that is multiplied by a 2. Now, just like in Gemma, we're going to go to our group first. Remember, that's our first step. We're going to go to our group. So let's see what happens. We're just going to focus on this group here in the middle. We've got a 2 distributing into that group. And so for now, this 3x can just kind of come down here and hang out on its own. This 10 can come down here and just hang out on its own. We're really just focusing on this group in the middle. So let's see what happens. I've got positive 2 multiplying a -1x or a -x. So let's see, it's a positive times a negative, so I know it is a negative. It is 2 times 1. This is 1x, so 2 times 1 is 2. And we bring that x along with us. We look at the second thing we're distributing into. We got positive 2 times -4. Again, positive times a negative. I know that's a negative. And 2 times 4, that is 8. Awesome. Now, we're not done. Notice that I still have more terms than I probably need. I've done my distribution, so distribution looks great. Now I have to combine like terms. my variable terms here. I've got 3x and minus 2x. So in fact, I've got 3 minus 2 for my coefficients. So I'm just going to have 1x. And in fact, because it's just 1, remember, we can just write x. Just write x. Let's come over here. We've got constant terms. So we've got -8 and positive 10. So we've got -8 plus 10. That is going to be a positive 2. If you forget how to do that, we're really just finding the difference between these two numbers. The difference between 8 and 10 is 2. That's how far away they are apart. And we're going to keep the sign of the larger 1. So we're going to keep the positive sign of the 10. So we actually have positive 2. And so to rewrite our simplified expression, we are just going to write x plus 2. We cannot combine those. One is a variable term, one is a constant term. But look at how much nicer that is than what we started with. We would call this the simplified expression. That's what we're looking for. We want it as simple as possible. Couple small things to look out for. This doesn't just work with integers. We can have fractions. I know, very scary, but if we had something like this, we can absolutely still distribute that 1/2. Well, let's think about that. 6 times 1/2, or 1/2 of 6 is 3x, and 1/2 of 4 is 2. We can still distribute fractions. We could do it with decimals. We could do it with all those lovely, lovely rational numbers that we've come up with so far. And then I will draw your attention to something that might pop up as you see problems like this. Let's say we had 3 times x plus 2 minus 4x plus 7 minus 9x plus 5. Now this is way more complicated. There's a lot more going on here. I think you could probably start to see where we would start to tackle it. We'd start doing our distribution. We could do that. We'd figure out that that's 3x plus 6. We would bring this stuff that's not in a group down with us, 4x plus 7. And then we run into this situation. We're subtracting. So we have a negative sign or a subtraction sign out in front of a group, but there's no number. There's no like 2 or 3 or 1/2. And I want us to just think about for a second what that means. This means I am subtracting one of these groups. So in fact, when we see this, we can think about it as a -1. We can take that -1 and we can distribute it in just like we would any other number. -1 times 9 is just going to be, it's a negative times a positive, so I'm going to get a negative, and 1 times 9 is 9, minus 9x. And I've got -1 times 5, which is -5. So notice when we don't have a number out here, if we just have a minus sign, we're actually just going to flip the sign of everything in there. Notice how 9x became -9x and 5 became -5. So be on the lookout for that situation. One last thing. There is a little bit of strategy in this. Now, I did say we typically do our distribution before we combine our like terms. We want to get rid of the groups first. But sometimes we might see something like this. Some long thing like this. Now notice here, there's similarly a lot of these terms as we saw before. We saw that up here. But now a lot of these terms are inside the group. We could definitely just distribute to everything if we wanted to. It's going to take quite a few steps, and we're going to have to do all of this. In fact, my rainbow is getting pretty big now. But there's something we can do first. Because we're looking at the group first, we can actually work inside of these parentheses. We can work inside of here. These parentheses tell us, hey, there's stuff happening inside of it, but we can work in here. And what we might want to do with something like this when we see a lot more terms is we might want to combine our like terms inside the group first. So here we've got x plus 2x plus 5x. And then our constant terms, we've got 3 minus 4 plus 7. So we've got 3 minus 4 plus 7. Now over here on the variable term side, again, x is just 1x. If you want to draw that 1 in, you absolutely can. We just like to put that as a shorthand. It's just x instead of 1x. It means the same thing. And here we'll add up our coefficients. So we've got 1, 2, and 5. So we're going to do 1 plus 2 plus 5. And in fact, we know that pretty quickly. That's 8. We know that. And so here we have 8x. Over here, let's see, we got 3 plus 4 plus 7. We can certainly go 3 plus 4 is negative 1 plus 7 is 6. We know that. We can do it that way. I'm also seeing, hey, I've got a 3 and a 7 in my positives, so that's a positive 10. Positive 10 minus 4 equals 6. There's a lot of ways that you can think about this and organize those numbers in your head to make it a little easier to work with. But at the end of the day, we've got 8x plus 6. Now that looks a lot more simple than the stuff that was inside the group before. Remember, we're still inside the group. And of course, we still have that 7 because we have 7 of these groups. Now, let's just make a little bit of space here. Just going to erase a little bit of our work so that we can see that at this point, we have a smaller group to distribute that 7 into. So we have 7 times 8x. And we have 7 times 6. Now these ones are doable. It's higher on our times tables, but 7 times 8 we know is 56x. And when we look at 7 times 6, we know that that one is 42. And so here is our answer, our simplified expression from all that nonsense down to something much easier, much nicer to work with. All right, that is everything we've covered so far in Unit 3 for algebraic expressions. That should get you examples of pretty much anything that you will see on the midterm for Unit 3 content. I will see you on test day. Good luck studying. Remember your cheat sheets and try to get some sleep. Bye, y'all.